Welcome to the SGX3 community webinar. I'm excited today that we're going to have Jeanette Spearhack from UCSD, one of the folks on the Blueprint Factories team who's been leading the AI Blueprint Factory project for almost kind of the last 2 years and doing a lot of work, as you'll hear about. She's going to present on the second Blueprint Factory that's being published actually today. Yeah, about a year ago, I think we published the Sustainability Blueprint Factory. So we're very excited to share the results of the report and all of the data and interviews that Jeanette has done a lot of work compiling. So you hear about that. So with that, I will turn it over to Jeanette to present.
Thanks, Sean. Hey, everybody. Let me get some slides rolling here, and we will get started. Like Sean said, I'm at San Diego Supercomputer Center. My name is Jeanette Spearhack, and I'm a senior research software engineer there. I was asked to lead a study for SGX3 called the AI Blueprint Factory, and we're going to talk about that today. Before we get started, I want to thank the core team that helped me to direct and guide this study. Rob Quick, Joe Stubbs, Christian Garcia, Chipan Chan, Ava Dielman, Amy Connolly, and Wang Mei Wu. They've been super helpful putting all of this together with me. So let's start at the very beginning and say, what are our, actually, before I do that, I'm going to interrupt myself and say, I bet there will be questions and comments and remarks. I'm going to try to leave time for that. And if you could hold those toward the end, that would really help so that we can get through the material that I hope to get through today. And then, there will be details in the written report, which is something we can't quite encapsulate in 45 minutes or so. So let me get rolling though. What our premise is for SGX3's Blueprint Factory on AI is that AI is a promising tool for scientific research. And this leads us to ask some questions. How can we encourage broader AI adoption and research? How can we ensure that the power users, the people with the really large models they're running, the huge data sets, people who are maybe trying to get together foundation models, how do we ensure we're meeting their needs and incorporating continuing innovation in the field of AI, but using it wisely? So if we agree it's a promising tool, and we ask these questions, how do we proceed? How do we make sure we're getting some uptake in research? And that is the point of the AI Blueprint Factory. So that said, here's our outline for today. We're going to talk about SGX3 and science gateways briefly. We'll dig into the AI Blueprint Factory and describe who we spoke to get our information, what they told us about, and what we learned, what we derived from these conversations. We'll go into the opportunities that people have helped us to identify, recommendations that we make, caveats and implications. A lot of this is at a general level, but I think it's early days for AI and research in some ways, and it's useful to make these kind of inquiries. So if you're here, you know what SGX3 is, and you know what science gateways are. But just so that we state our terms, SGX3 is a group that supports and encourages the use of science gateways, and science gateways are those web-based platforms that we provide for specific scientific disciplines in many cases. The idea is to lower the barrier to computation and make it easier for people to get to real scientific data and software and computing resources, the big stuff, right? This is helpful for students, for teaching, for one-offs, for showing people new and impressive tricks on the large hardware that we support as a nation. So science gateways are really super tools for some of these things. And SGX3 does a beautiful job supporting those. Now, the blueprint factories that SGX3 has proposed and is delivering on are studies that each focus on a specific emerging topic and that are geared toward determining capabilities that are needed to support future research, and really that'll create a blueprint for future cyber infrastructure and for science gateways. And in a way, these studies are bigger than science gateways, right? They're really geared toward both the science gateways and what they do, and also the cyber infrastructure in general, the kind of compute that we are needing and delivering in this country so that researchers can use it. So in the particular case of the AI Blueprint Factory, this is an interesting case. We've identified AI as something we want to talk about and consider and encourage the use of. So we get experts together who are researchers that are working on delivering cyber infrastructure to support AI and research, and also folks that are doing domain science research with the assistive AI. We'll talk a little more about that in a minute. But what we did, we get these folks together and we conduct interviews. We talk to them about how they're using AI now, what they wish they had, what they're grateful for, what their goals are. We analyze these conversations and come up with recommendations, because what we're trying to do is really get a feel for where researchers are going to need to go over the next 5 to 10 years, and how we can assist them and make sure AI is accessible and something that they can dig into and make use of to inform their research. So when we talk about participants, these are people who are already using AI in their work. They come from a variety of scientific disciplines. They have a variety of seniorities, so number of years since their degree. Talk to everybody from graduate students up to senior researchers. And institutions have varied too. We spoke with people at national labs, and we spoke with a lot of university people from R1s, from R2s. And then there's the AI question, right? People are using a variety of techniques on an assortment of research problems and coming from different, for lack of a better term, how about AI areas, right? Some folks are focused on cyber infrastructure or data or algorithms. So defining our terms, what do we mean by using AI? That's going to be an important thing to notice. While it's fun to generate wacky pictures, and while we all use, I think, a lot of the large language models to help us with copy editing or phrasing letters or different tasks, what we're really talking about here with respect to research use in AI is non-trivial stuff, right? We're not talking as speculative as AGI, as general AI, but we're talking about specific things that you can do in your research that are using the techniques that are available now and looking forward with those. So I hope that makes sense. Not talking about, hey, I use ChatGPT to do things around the edges. We're really looking at substantial AI use in research. So what do we mean by that? Let's talk about that in particular. So just to take 6 examples, here are some of the things that the researchers we spoke with are doing. They're creating digital twins to live patients so that they can forecast disease states. And these are done using AI models. We have people who are specifying particular properties that they want an alloy or a material to reflect. And they're using AI models to discover new combinations that might hold up in the lab. They're using AI to design new scientific instruments that are either sensors or maybe antennas of different kinds to detect certain signals, right? They're using AI to develop data compression algorithms and a great number of very interesting optimizations. And they're even using AI to safety test AI models, right? And build models of things, including living cells, down to time series data and very detailed information. So all of these are things that some of the individual researchers we spoke with are actually doing using some AI methods. So we spoke to people, and all right, how do you know we've spoken to enough people? I guess the question, data collection, are we there yet? And what is the measurement stick that we use for that? Might be a question you have. How do you know your study is complete? For this, we rely on social science, who, in social science, people use a lot of surveys and a lot of interviews to get done what they need. And there's a concept called data saturation. And we have here the sort of analogy of color saturation in pictures. You don't want to have too little, because then you don't really have a defensible study. You don't want to have too much, because then you've made yourself more work than you need. So in social science, they find that you want to interview enough people that new interviews are really only repeating ideas you've already heard. Now, and you want to push on that boundary a little bit until you've got enough. Typically, data saturation arises around 15, anywhere between 15 and 80 interviews. It's a pretty big bin, isn't it? But we've got a fairly focused group of target participants here. So we did find, just with our own experience, that around 20 to 25, we were definitely hearing the same things again. Not that we weren't talking to people doing innovative stuff, but they're encountering the same kinds of barriers or opportunities or issues. So we went to 30 interviews, and I feel that that's really quite defensible in terms of data collection. So let's talk about those researchers that we spoke with. As I mentioned, we have a variety of disciplines reflected here. You can see that 9 out of 30 were computer science, 6 were from the physical sciences, and I had 5 each in the medical sciences, in engineering, and in a combination of social and biological sciences. Now, you look at that and you think, boy, that's a lot of computer scientists, isn't it? But I think that this is defensible, and I would say that this is intentional if you consider that AI is really something that is originating from computer science. This is where it comes from, and these are the people who are who have generated the ideas, the software, and are creating cyber infrastructure to make it happen. So this was really something we wanted to do to make sure that we had a good basis in talking about AI and its possibilities and limitations. So as far as researcher seniority, you squint, maybe you see a bell curve here, but everybody from 4 graduate students, a good helping of early career and mid-career participants, and some senior researchers as well. And then for AI area being, here, data, algorithms, or cyber infrastructure, we ask people to self-report and say, what do you mostly do with your time? You can see that there's a good amount of overlap. And if you're adding up all the numbers, you'll notice that we're at 29, because I have one researcher that we spoke to who said, you know what I do is ethics. I don't do those other things. So that covers all 30. So then research problem. This is a really fun one. As I mentioned earlier, we spoke with people who do a wide array of things using AI. So here's kind of the way we ended up skinning it. 5 people in scientific emulation. So scientific emulation here means they use AI models to replace maybe computationally expensive solvers or simulations. So to speed up particle physics simulations, or to perform spatial integration. So if you take a model, you drop it into this expensive calculation, and you let it do its magic to shrink things down. Obviously requires a lot of validation and verification, but these are people doing scientific emulation. We have predictive modeling folks. So that's 6 represented researchers in this data set. These are the people who are using AI models to make probabilistic predictions of risk, forecast outcomes such as disease states from data sets, or from digital twins in patient examples. So scientific discovery, we had 6 participants there. We spoke earlier about people who are designing scientific instruments using genetic algorithms, people who are designing new metallic alloys based on the properties that they'd like to see. So that counts as scientific discovery. We've got knowledge retrieval. 3 people there were using natural language processing and tuning large language models, maybe for specific populations and specific information, or to operationalize them. And then we have computational infrastructure folks. And this is a great big bin, obviously, almost maps to the folks that come from computer science, right? So these people are working on governance and safety of AI, finding ways to study AI reproducibility, and also just making available software that helps with the construction of AI workflows and so forth. So those are the kinds of research problems that we're looking at here, and these are the categories they cover. Okay, so overall, we talked to these 30 researchers, and it was pretty exciting. We see that AI is being used in domain research in a great wide variety of research problems, and it's really becoming essential to researchers' work. It's hard to imagine, taking the optimization away that you've found yourself able to make using AI models, for instance. Interestingly, using AI in domain research is resulting in both very creative uses, really interesting innovations, right? As well as optimization, as well as shrinking down the time or the resources needed to get something done that we're already doing in research. So I hope this explains to you what our data set looks like, and the kinds of inquiries we're making, right? We'll take all this information, and where do we go from here? I would be remiss if I didn't mention how we went about this. I'm a software engineer, so I like to use software for things, right? Also, when confronted with 30 hours of interviews, here's what you do. We did everything, all of our interviews using Zoom software. We recorded those interviews and we auto-transcribed them. Use of AI to save time. Yes, exactly. We did a little bit of scripting to take those text transcripts and remove names. Our institutional review board agreement with all participants said, we're not going to use your names in this study. So that was just part of the arrangement. So we took out names. We did some summarization with large language models. Let's see, we used Notebook LM, and I could, if you like, look up the exact release that was used on this study. The summarization was really for our little human brains, which, it made it easier for us to read through these things and understand what we were grasp quickly, what a given interview was about. We used some of these transcripts and summaries. We queried the LLMs on these things to draw out themes and to explore what people were saying. But I want to emphasize that we went back to the original transcripts. We went back to the original recordings. We made sure that we weren't participating in any kind of mass hallucination, right? We want to be certain that we're drawing conclusions that are defensible and correct. So what do we learn from all of this? Well, there are 4 big themes here. These are the challenges we identify that we think are being presented to domain research that wants to use AI. Okay, so let's dig into these. First of all, we've got access to computing infrastructure. So let's look at that for a moment. As any of you who have been buying hardware lately know, it's cost is tricky. So the summary here is comes down to cost, competition, and size. Really, because of demand, because of all the many people and institutions and companies around the world that are trying to use AI on things, costs for hardware are really up. You can see it says here, the last year or so, costs for hardware are up 3 to 4 times. Deployment cost of high performance computing per petaflop rose by 17% in 2024, something I saw in a study. So cost is tough. Competition is hard, right? So even on the big national systems that researchers are using, they're great systems, but they're oversubscribed. And the people who are really the big users, right? Super large data sets, they need fast interconnect, they need GPUs or TPUs, they need the heavy stuff. They're having to scale back their computations. They're having to limit the degree of complexity in some of their inquiries, just because otherwise the waits are so long. So it's not good if we're compromising research because of this competition. That's tough. We also note some of the researchers were mentioning, Academic systems, we've tried hard to supply these and to make sure they're available to researchers, but they are smaller than what's available in industry, and that's biting us a bit. So, all right, these are the challenges. What kinds of things are capabilities that we should offer? Well, at a basic level, right? We want to make sure that we've got AI capable hardware infrastructure that's available to people, right? People who want to do research with this, it should be available. That infrastructure should be running appropriate software frameworks in a way that they can get on and make use of. And also that infrastructure should offer error recovery and checkpointing. This is going to make it ultimately more efficient, more straightforward to run the calculations they need to do. And additionally, it's imperative that there be safety and reproducibility concerns folded into this infrastructure that's offered, right? We want to be able to prototype things, to verify things, and to make sure we can do them again, explain them. This is all really part of offering proper infrastructure for research that uses AI. So how do we go about that? What can we do to make it possible? And so we could argue here that, excuse me, I'm clicking around and it's not helping me, is it? There we are. Research software engineers, that's RSEs, are the folks who can help with some of these questions, right? They kind of sit between, on the one hand, computer science people who are doing, computer science research, and on the other hand, the domain scientists who are doing something in the scientific domains. RSEs are sort of the bridge between these places. If we engage them to build some bridges, to build some software, to optimize, to make it easier for us to offer more cycles more efficiently on the big hardware that we support nationally, maybe this would really go a distance to help us. Supposing we collaborate with industry, this is already being done, and I applaud the folks that are doing so. For instance, as a part of the NAIR pilot, there are a number of companies that are offering cycles on their machines. This is wonderful, and it's the kind of thing that's going to help with getting research done. Prioritizing academic work, we need to weigh sort of how important, how much do we value academic work as a society? How much do we want to fund making sure that it gets done? I guess that's really always a question, but it's certainly a question when it comes to making equipment available. So documenting failures, isn't it good if we can indicate ways that our computations failed, that our models didn't work? Blogs, maybe communications in journals or at conferences or in webinars such as this one. We want to be able to share with one another. We want academics to be able to say, hey, listen, this didn't work, but let's try this. If we can scale back on the cycles we're using to repeat things that didn't work, boy, that would help us all. And finally, I want to point out the efforts such that NSF supported and put together, such as NAIR and Access, which make large compute infrastructure available to the national research community. And these are marvelous programs. They are examples of the kinds of things we need to do going forward. And we need to make use of them and applaud them. So the story would go for addressing access to advanced computing resources. We want to improve efficiency. That's going to help everyone. We want to both forge industry partnerships and deepen those, and we want to affirm academic partnerships. Consider maybe cases where several universities can go in on a single compute center for AI use. We want to engage human capital, such as the research software engineers and other folks who are becoming versed in supporting AI and the pipelines and software it needs. Documenting failures to prevent repeats, and considering and weighing the value of academic research in our society. These are all things that are going to help. So, next challenge, data management. Data management for AI is really a bear. And I thought about giving you a flow chart, and you don't want to see one of these, right? I mean, there's getting access to the data and storing it. And then there's data cleanliness and making sure that it's really representing what is needed. Is the data complete? Is the metadata complete that describes how it was collected, when it was collected? We want to make sure that if we have protected information, either because it's healthcare information or because it's possibly content that's owned by someone, we want to make sure that we're not treading on toes and doing things that aren't fair there. The other point is provenance, where depending on a particular run, you want to know what model you're using, what data set you're using. All of this needs to be documented in certain kinds of computations. So data management for AI, it's a big chunk to bite off. This is going to depend on the kind of models you're running, the kind of data sets you're running, what your inquiry is. But it's really a big challenge that we saw repeated across the board, although the details can vary. So what kind of capabilities do we require for data management for AI? Well, how about standards for metadata? How about fair data repositories, where fair is that findable, accessible, interoperable, and reusable acronym? We want to find ways to create integrated processes so that we can do data handling and do provenance handling and documentation. Again, this is a place that's ripe for developing more software and making it open and making it something that can be configured. Additionally, we want to make sure that security and safety and privacy are considered, and that bias is characterized, because data are going to be biased. You just have to study and understand what those are. So there's a whole lot of capabilities we need there. And rather than repeat myself, I'm just going to give you the here are 6 points, right? Standards for metadata. That's a big ask right there. Data pipelines and processing, well-characterized bias, fair repositories, which itself is a big task. We want AI-ready data to be safe and ethical, and to be assembled with consideration of privacy and integrity. Okay. Point number 3, democratizing AI access. We want to support the big users, the power users, but we also want to support the people who are coming into using AI on their research. And so this is a challenge. How do we help people to find the computing resources? So resource discoverability is the way that we'll phrase that. How do we make sure that we can easily get people allocations onto the big computing resources, that we can get them onto the big computing resources, and that we can train them to use these? Also, we need to address knowledge gaps. So people need to understand how to choose the right resource and how to go about all of this. So capabilities and approaches, we're going to fold them together for democratizing AI access. Here's something that we can do to deliver information to new adopters, or to people who are maybe trying a new flavor of AI for their research problem. On the one hand, we have human facilitators who can specialize in particular corners of the infrastructure, or particular corners of software or other, and they can give human assistance to people, tutoring, answer questions and so forth. On the other hand, we can make use of AI tools and AI assistants that can be trained up on the documentation for some of our compute resources. So these 2 prongs toward helping people to get on the big machines and helping them to use them, I think could really go a long way to serve the folks who are trying to adopt AI for their research. Backing science gateways, which are, after all, a great way to give people an on-ramp to computation, is something really we should do. And using those science gateways to offer use cases and examples, tutorials, notebooks, all kinds of places where people can get on and experiment and say, this works in this case, and here's how I can take this forward. And we need to make sure we teach and train. Teaching is going to be imperative here. So For democratizing AI, we want to put forward science gateways. We want to explore both using machines and human facilitators to provide tools and assistance to new adopters. And when we want to offer plenty of good defensible use cases and examples so that people can pick the right kinds of models for their problem, do appropriate things with their data sets. This is challenging. We want to help. Resource discovery and usability, I've said it before, but these challenges intersect with each other, don't they? It's something that's important for democratization as well, and training, plenty of training. Okay, our last quadrant is responsible AI use, and this is a big one. This is a big one. Correct technical operation of AI is really critical. Sometimes tracing your way through how a result came to be is very difficult. We want to have explainable results. We want people to be picking appropriate models for their problems, appropriate data for their problems. And this can be really hard to do unless you've gotten your feet wet and gotten some training and some feedback. We want to address bias in our data sets and models, and we want to consider the environmental footprint. All of these things contribute to responsible use and are challenges. So there are a number of things that researchers suggested when we spoke to them, things like dedicated AI test beds where people could verify and validate their results, where we could test out new workflows and this kind of thing. Straightforward resource allocation rears its head again. We want people to be able to get on easily so that they can use what they need. Tools that we can generate for composing and monitoring workflows will make it easier to put things together and easier to determine that they're working correctly and defensively. And efficient implementations, good software, optimizations, all of these things are going to contribute to responsible AI use. So we want tools, we want teams that work together and are sufficiently diverse that people can give each other guidance about, hey, is this data set okay? Do we need to approach this problem a different way? That's another way to close the loop with responsible AI use. Education and training, it's back. It's something that we need to make sure we offer to everybody from seasoned researchers who are picking up a new area on down to new researchers or even graduate students who are trying to figure out how to use these powerful techniques. We want to keep humans in the loop. I have a great story that one researcher mentioned to me, right? He said, well, when you're supervising a student and they come in and they have a great idea and they've done this calculation, you don't say, great, let's publish, right? You sit down with them, you ask them questions, you look at their method, you question them carefully about what their intent was, where they were going, and maybe you send them back to make some adjustments. And this is really how we want to work with AI too. We don't just take what it gives us. We are very careful and step through in a nuanced way. We test, right? It's a simple way to put it, but when you're working with a machine in this way, you want to make sure that you're dealing with that you're not having some unexpected things crop up. So humans in the loop. It's an important part of AI use that's responsible. And finally, we want to optimize for efficiency. So making sure that our use of these amazing techniques are efficient. So this is a kind of a big slide, but it's fun to read off, right? We want appropriate model choice. We want to understand our data and have human oversight. And we want our responsible use of AI to be transparent, explainable, testable, reusable, safe and ethical and efficient. That all sounds great, right? But how do we know when we've gotten to where we want to be? And I guess we roll back to the beginning of the talk this way, right? We want people to be able to take AI methods and incorporate them into their research. So maybe what we need are some criteria for success. These are the kinds of things we write up when we're putting together a new grant. We want to count up things. So how do we count up, how do we generate the right kind of metrics to ask whether we're getting where we want to go with AI adoption and research? Do we count up domain science papers, reusable workflows, maybe data repositories that are fair? How much uh, supported AI research is taking place? RSEs who are doing the work, centers or institutions, or time to first use after taking new training? This is something we're going to have to develop and consider over time. Just like a lot of the things that we've covered here, there's no this is the answer. It's early days in some regards, and we have to keep asking ourselves the questions and maybe iterating a bit. So overall, when all is said and done, there are kind of two things I have to say. We have some opportunities here for AI in uh, domain research. We need to democratize access so that people have access to the compute resources they need to get the AI work done. They need access to training and examples, and they need ways to get their data ready for use with AI and distributed to others who need data of the same kind. So democratizing access. Secondly, fostering responsible AI use. So we want these models, these tools to be reusable and explainable. We want to understand the provenance of each calculation, where it came from, how it happened, and we want human oversight so that we're not cutting corners and getting sloppy. We want to know how we've gotten to our answers. So overall, there are recommendations that arise from these. We want to encourage development and lots of it. And this is where we can use the skills of RSEs to develop data pipelines, tools, and techniques so that researchers can get in and use AI methods on their science. We want to support and grow gateways, and these gateways can help with the teaching of AI and hosting things like examples, notebooks, tutorials. We want to forge industry partnerships and deepen them, and we want to continue partnerships across academia so that we can make sure these tools get built and make sure uh, these compute resources get hosted and are made available. And finally, we got to work to identify the criteria for success. What do we want to say that we achieve? So I've kind of alluded to this along the way. I know that making generalizations like I've been making for the last 45 minutes they're big, right? Technology is evolving really rapidly, especially in AI. It's been amazing to see how quickly things happen, and that makes it complicated to make generalizations of this kind. Um, Different research, different problem types, different scales and types of data sets, and different kinds of techniques are all going to need you're going to need different kinds of resources, software with different capabilities. So it's really complicated to speak about this, but I think it's also really important to survey the population, see what people have to say, and start the hard work of describing how we move forward to make sure that people can use these amazing techniques to smooth out their research in places to make it deeper, to make it more optimized. So the implications for gateways and in fact for computing resources in general, it's already true. AI methods are shaping scientific research. So researchers are going to need, GPUs, CPUs, TPUs, you name it. They need the hardware, they need the models, and they need the AI-ready data. We have to support AI education, use cases, examples, and support for researchers and their students. And we've got to just continue to learn and expand opportunities and offerings as we go forward. So that is the talky part of this presentation, and I want to thank the SGX3 folks named here and the Blueprint Factory core team, especially though all the researchers who volunteered their time and insights and helped us to put this together. Thank you.
All All right. Thanks, Jeanette. That was awesome. So yeah, I think at this point we can start doing some questions, and I'm going to post a link to the AI Blueprint Factory final report here in the chat for folks.
Yeah, there are a lot of details that we couldn't get to here that, well, there will be some more enlargement of those in the report. So it looks like there's a chat remark here about the lab notebook and what does it look like now in the age of LLMs and AI scientist assistants? Should researchers be required to report their LLM usage, model details, and specific queries and chat logs? That's a very good question. I mean, as of now, right? Maybe you're copy editing something. Boy, does that count? Um, this is a good question, and it's something we need to consider. I don't certainly have an answer, but yeah, the lab notebook. I mean, you have to consider too, we don't publish all the contents of our lab notebook, right? You run on for pages and pages. You run on through the things that didn't quite work. So we have to figure out where to draw the line there. Excellent point, though, Russell. Thank you. It looks like Ani Thakar has a question. Would you like to go ahead?
Yeah, so I just want to make sure I understood one of your earlier slides correctly. So I think it showed that the maximum number of AI researchers were researching computational infrastructure.
Yeah,
What
there
exactly
were.
did that mean?
Yeah, sure. So the people who are doing computational infrastructure work were doing an assortment of things. In some cases, they were supporting the uh, the large compute resources or software that runs on the large compute resources, or they were developing ways of building AI workflows, or they were doing research on things like reproducibility. So things like that. Does that help a little bit?
So I just want to understand where they were coming from. So these are IT people, you think, or?
No, no, not IT people. I mean, in a sense, maybe, right? Like to some degree, computing center staff, right, who are charged with
Mhm.
doing things like studying governance and safety. So in some cases, they might be, yeah, folks like me who are doing, who are staff attached to universities and to computing centers. Does it make sense?
Okay, so I was just wondering, how do we address that? So if a lot of people are still sort of trying to research the infrastructure, then is there something lacking?
Oh, I mean, I think the infrastructure is also evolving, isn't it? I mean, that's one thing about this is that any study of this kind is a snapshot because things are moving very rapidly. Um, and I think you're right. I mean, can we make the infrastructure more? Can we make it more robust or more efficient? Um, are there going to be innovations that come out that make it possible to support these things better? Absolutely. So uh, would I say it's lacking? Maybe that's too pessimistic for me. I think we're moving forward, but that doesn't mean we've got nothing, you know? Does it make sense?
Yeah, maybe we're not documenting it well enough.
No? And documenting is always an important step. Yeah, thank you for your remark. It's a good one. What other kinds of things are coming up? If you have questions that we can't answer, hey, that's there are lots of questions that we can't answer that are cracked open from a study like this. So please feel free to voice yours if you wish.
All right. I guess if there's no other questions right now, again, thanks everyone for coming to the webinar. Thank you, Jeanette, for that great overview of all of the hard work over the last 2 years that you put into doing all the interviews and compiling all the data and everything. And we're very excited that now that with the release of the AI Blueprint Factory report. So again, I'll link it again in the chat in case folks missed it. But so yeah, there's a link to the report so you can go through and see the details and everything. So and yeah, feel free to reach out to to anybody on the team if you want to follow up or have additional questions.
Thanks so much for attending, everybody. Really appreciate it.